Okay. We're a few minutes past already. I don't want to crowd the next one, so I can go ahead and get started. Yeah, so happy to be here at Langdev. It's actually my second time. I was here a couple years ago, and I missed the last one, so it's good to be back. So today I'm going to be talking about Langium AI, in particular just talking about building AI applications for Langium DSLs. And I'll go into this in kind of a nice little introduction. And I kind of am, yes?
Maybe you should have the mic.
I asked, yeah. I would actually have no problem if I actually had the mic. I saw it before. Yeah, I can hold that. Oh, good. Okay. Thank you for asking that. Case in point, if anyone has a problem hearing me or has a question about something, don't hesitate to interrupt. I really don't mind it at all. Totally fine with that. Okay. So for a quick overview of the talk today, I'm going to do a little introduction for myself and the company, some background about the topic, the problem that kind of motivated us to look into this area, the solution we proposed, which is this Langium AI framework, and the implementation that is the framework, a demo, and then a quick wrap-up afterwards. Okay, so quick introduction to start with. So yeah, that's myself. Older picture, my name is Benjamin Friedman Wilson. I work as a language engineer at Typefox since 2022. Live in Germany, but originally from the US. And I do a lot of work on domain-specific languages, in particular with Langium. And I also tend to build a lot of full-stack applications that usually have like a DSL at the core. Again, usually Langium. And just to kind of give a quick sense of Typefox, if you haven't heard of it before, we work predominantly with like providing language engineering services, cloud and desktop IDEs, modeling and diagramming. This just is the stuff we state on our website. We do more than this as well, but it's kind of like the core focus that we emphasize. Okay, and now some background that kind of sets up for why I'm giving this talk today in the first place. So why did we even really bother digging into this in the first spot? Well, there's like two core reasons that stood out to me. Langium, so it's a language engineering framework that we've been behind. I'll also do a quick slide about that later. It's been doing really, really good lately. That's awesome. And AI assistants in general have been doing really great. So things like Copilot, Tab 9, Droppic, ChatGPT, Insert XYZ there, they've been doing pretty well. And this is okay, but it leads to a lot of the following questions where how can I get AI to work with my DSL? And for Langium-based DSLs, it's usually not in the model. So it tends to be a bit of a problem. And yeah, for novel DSLs, there's also not a lot of training data sometimes. And there's not many examples to go with. And it varies. Sometimes you have more or less. But like, especially if you're working with a DSL that's moving forward pretty quick, you may even be changing your examples as you go. And as I said, I promised a quick aside on Eclipse Langium. So Langium, if you're not familiar with it, is a language engineering framework that's written in TypeScript. It's based on Chevrotain, which is a nice parser builder toolkit. Gives us pretty high performance. And it runs server browser wherever you can run JavaScript, basically. It provides LSP support out of the box for your DSLs. That's one of like the key features of this thing. And it's highly customizable with pretty good defaults. And it's also an Eclipse Foundation project. And if you haven't heard about it, that's okay. Just think Xtext. It's similar to this in that regard. It's different, but that's kind of a good area to kind of base your knowledge on. Okay, so now the problem. So kind of a reformulation of what I already said before, but this comes up a lot. Can I get AI to support language XYZ? And well, it's kind of a loaded question. Sometimes it's yes, but why? And sometimes it's no, and why? This is kind of too binary, maybe. It's more gray than that, but this does come up quite a bit. So yeah, if you want to get a model to support some language, generally speaking, of course, this is why things like Copilot are doing so well right now. And with Langium DSL, kinda, that's where it starts to fall off because, again, it's novel. A lot of times it's not in the actual training data. And it depends. And usually the results are not very good there anyways to start with. Because even if they're kind of okay, that's not going to work. Code that kind of compiles, it's not okay. But they're getting better, but it depends. And it really depends in one key concept or context, which is Langium itself. It's getting support passively, again, because Langium has been doing so well. Actually, I totally forgot from the prior slide where I had that chart, and I said nothing about that chart. That's the total downloads that we get through NPM, and it just went like bonkers over the last year. So we have no shortage of like Langium examples to have into like training data and such. So you can already find, if you like prompt correctly in like GPT or Claude stuff, like you'll see kind of verbatim the examples that we've written in Langium pop up, or other popular projects based in Langium. So that's cool, but it really doesn't help us with the actual DSLs that are based in Langium. It's a step in the right direction, but it doesn't quite get us there. And so that's really the crux of the problem: how to get AI to support or to provide support for novel Langium DSLs. So to kind of step more into the problem there, specifically, the issues with supporting these DSLs are that we don't have a lot of pre-existing training data. And again, it's not in the model in that case, is how you can phrase it. And often few or limited examples, again, kind of a restatement from before. And the documentation is often limited. So, important points. And this is often kind of exacerbated by the fact that the language is often evolving. So these points may be obvious to some extent, but like, even so, it's a moving target. So you can nail these points, and if your DSL is novel and you are changing things, you're going to have to keep changing stuff. So just to kind of recap over that, the whole problem here is that we need a way to build AI agents with DSL knowledge. We need a way to be able to iterate on the agent and the DSL in tandem. Because again, we're anticipating that a lot of these DSLs are maybe not fully mature yet, but they expect to get some feedback, like some client wants something with it. So we need to be able to do that. And we need to be able to reasonably trust the agent's results. That's very important there. Okay, so that brings me to the solution, which is the core title of the topic, which is Langium AI. So this is a proposed kind of extension to the Langium engineering framework, and the idea is to tap into your existing Langium DSL. And it then leverages your existing DSL services so that you can get two kind of core aspects right now, which is DSL doc splitting and AI app evaluation. We'll dig into these more in a little bit. I really felt like I wanted to do the rule of 3 here kind of thing and have a third one, but the more we came back to this, and we've done quite a few iterations internally, the more we kind of dialed into really these 2 core points. And naturally, it's also written in TypeScript, so you can kind of bind tightly with Langium too. All right, and also just a quick what it's for and what it's not for, so you don't get misconceptions here. Langium AI is intended to be for people who are working with Langium developers. And it's also for those who need an agent for an LDSL, or Langium DSL. It's not necessarily for ML experts. That's not to exclude the fact that if you are or well-versed in this area that you can't use this. It's just this tool is not designed in such a way that it excludes you if you don't have this knowledge. That was a key aspect up front. Again, a lot of us are versed in programming languages in theory, so wanted to kind of keep it based in this area. But it's not for replacing existing models and stacks, fine-tuning models, or doing additional training. So the idea is that you already have something in mind, or you have something that works. And that really, this last sentence here, I can't really state this enough. The idea is that this complements existing AI apps that work with or support Langium DSLs. So this really is truly in complement to what you are already working on or planning to work on that is Langium-based. Okay, so then where does Langium AI fit in? So I kind of oversimplified the process of developing a AI application into kind of just 3 steps, omitting the obvious feedback that you would have between development and evaluation. And I wanted to kind of show that we see it really lightly in the development phase and really heavy in the evaluation phase. Initially, when I actually put this together, I was thinking about it because a lot of the development is just the evaluation of what you have built. And so it really is critical that you can properly evaluate what you are building. Otherwise, it's potentially just a waste of time and money. And that's not great. Yeah, and the development part, we see this as having the kind of the splitting is where this is supporting. And for evaluation, evals. So those two spots here, very, very simple. I almost didn't even need this one. Langium AI is composed currently of the splitter and the evaluator. Yes?
If you elaborate on what you mean by the splitter.
Absolutely, yes. No, thank you for asking. Yeah, again, yeah, I'm open to that. If you have like a large DSL document and you want to feed it into a database for, say, a RAG-based application, if you're familiar with that, and you want to use it like as a search item to look up. For a series of small examples, this could be okay, but if you have thousands of documents and they're quite large, maybe you want a section of a document and you want to be able to split it syntactically or even semantically. So I think it's later in another slide, but it's a very good question because sometimes you actually don't need splitting. In fact, I think I actually ran some tests. In some cases, it's not helpful if you have a lot of smaller examples, but as your data set grows for what you're actually using for yourself to train or just for RAG-based stuff, you have to watch out for how you're actually processing that. And you can use generalized splitters. There's some really great ones out there, and honestly, they usually work pretty well. But sometimes you want to split in a more logical fashion with respect to your DSL's actual syntax, which again, if you tap into Langium, you can just get that through the abstract syntax. Yes?
By DSL document, you mean the...
Like program text.
Right? Not the programs.
No, well, I mean the program text, but you could also think of it like the meta model, the parse AST.
Because you mentioned the original problem was that we don't have any training data for the DSL, not the code.
Yes. Yeah. Yeah. Okay. Cool. Okay, so then the splitter, again, it touches right on that point. I should have just run to this slide. It assists, yeah, in breaking up those larger documents. So if and when this is a problem, and it usually comes up for RAG-based applications, that you can actually split by, some larger level constructs like functions, blocks, etc. You can actually already find splitters like this for like Python and such that literally just split by the logical blocks, aka the actual like function blocks in Python. And again, this helps reduce larger documents, and it can help remove redundant chunks. So if you have a lot of different projects and you have a lot of the same code showing up multiple times, you probably don't want to keep putting that into the database over and over and over again. Maybe you want to just build relationships on that. So, and yeah, just splitting using the syntax. Okay, and the evaluator produces metrics from input and output pairs. So these are really just, I give a prompt and I get a response. They say, how are you? And it says, okay, kind of thing. Bad example, but so to speak. It can also include context history as needed, and the idea is that the evaluator should collect the metrics that you have into some reportable format.
Sorry.
Yes?
Metrics for input output. So you have a set of input and output.
Exactly. Yeah, exactly. Yeah. In fact, that's...
Create those.
Yes, you need to create those. In fact, that's actually something that I didn't write in these slides, but I probably should put it in here. You can't do this if you don't have good data. And you need data. You need input outputs. I've looked at a lot of this before, and there's a camp of people that say you can totally synthesize input-output pairs, and you can. But it comes with like trade-offs and drawbacks potentially. And so in this framework, we opted currently to not do that. And that's another thing that I want to touch on. It's like at the end of the slide, but this is still very early on. This is the first time I'm actually really talking about it actually at a conference. And so we will change this. We will adapt this as the needs are suited. I think at the very end, I basically say that practical demands will drive where this framework goes. Because if it doesn't meet practical demands, then it's not doing what we want it to do. Yeah. Hopefully that answers that.
Can you give an example of one such metric?
Of one, yeah.
One such metric, an example of a metric.
Yeah, like a parser error or a lexer error. And also, well, if you haven't used Langium before, you can define validations. And the validations turn into diagnostics. And the diagnostics can be of varying grades. And so you can have like info, hints, warnings, error. It's literally like what you see in VS Code. It's the same diagnostics. So we're talking about taking those same diagnostics that you already spent time and effort into, and I'll just jump to the next one here. Yeah, let's just iterate quickly and maintain trust. Because again, we don't have diagnostics, and we can't actually trust what's coming out. So the idea is that you already put time and effort into your language in Langium to add these diagnostics, to define them in such a way that you can trust what's coming out, and if it isn't correct, that you can actually, understand it in a human-readable fashion. But the human-readable code or the human-readable text has a code to it, and the code corresponds to a concrete type of diagnostic. So you've already done this, ideally. So you can leverage that pre-existing work that you've done to kind of check your language to actually check the output from something else. So just avoiding doing the same work twice. Okay, and then the evaluator results. This is not what comes out. I just put a chart there just to demonstrate. But it captures your input outputs that were used, the metrics that are generated from those input outputs, specifically in comparison to the output you expected and the output you actually received. And then, of course, some maybe additional metadata like runtime and such. And yeah, the idea is that you should be able to use this for comparative analysis, i.e. apples to apples. So you should be able to say, AI application A and B. Regardless of whether it's RAG or whatever model family it is, you should be able to put these aside and say, okay, how are they doing on the same metric basis? And I really do mean that. So this is a run that I did before where I was just testing some stuff. And I had a couple of Code Llama and Code Gemma here, a bit older, but still nice. Llama 3.1 and 3.2.3b. That's really small probably, but the red is Llama 3.1, the blue is Llama 3.2.3b. Hopefully that is reasonably legible. But the idea was that I could just take that data, those metrics that I got, and just show it in a radar chart. And the idea is then if I'm using good metrics, then I could just look and see that one apple is better or worse in regards to how I've shown these metrics than the other. So a keynote too with radar charts, they can be a bit deceptive. If you change where you're positioning things, you get a different area. So you have to be careful with that. But assuming you have picked a good representation for your data, you can get good results. It can help guide the process. And this is just generated using Plotly. It's not in the framework, but it was really easy to pipe this in. And this is actually inspired by weights and biases, by the way, if you guys haven't heard of that tool before. Great tool for machine learning projects. They also use radar charts to do this exact same kind of checking. Okay, so now an overview of the splitter and the evaluator. Right, okay, so the same section before with the splitter and the evaluator there, and in this area, your Langium DSL. And so in this case, I've just highlighted three kind of aspects that are relevant to how this is working. Your parser, validations you've defined, and a semantic model. For this sake, we'll say the validations are also some that come from your parser, so parser errors and lexer errors. Now for the splitter, it's predominantly using the parser and the semantic model. So the parser, obviously, using to actually take your documents, parse them, and the semantic model so that you can actually determine how to actually divide those documents based on that semantic model. And then for the evaluator, it uses both the parser and the semantic model, but it really leans heavily on the validations. That's key. Again, it's implied here, but if you've written a language with good validations, you should have already good metrics. You just have to use them. And so we leverage that here. You still need to parse, of course, and you still probably need the semantic model maybe to do structural checks, because just because you've checked your validations and they look great doesn't mean that you actually got something that is structurally correct, or even semantically correct for that matter. And to kind of dip into the evaluator a little more, the way we've currently designed it, and I'll still do a code demo at the end, I'm kind of watching time here. They're defined as a matrix. It's a lot kind of like a GitHub runner, if you want to think of it like that. So basically, those are runners by evaluators by cases. And your runners are invocable. They take some input, they run it on some model or a model stack, and it returns a result. So a really good example for a runner would be something that accesses ChatGPT 3.5 or something, and it's just in a function. And it takes some input, and it runs it, and it gives some response. It could also be local via Llama. It really doesn't matter. It's an abstraction layer. The evaluator defines a strategy to assess a given response, provided some case. Again, those input-output cases from before. And then the cases define an input-output pair that you want to assess, also ideally with metadata. Okay, and there's also a Langium evaluator that's provided currently that uses those validations that come naturally from Langium as metrics. Okay, and now I actually have a demo. And oh, good, time's okay, I think. All right, so the demo's going to be kind of a two-parter. Let's see, desktop 1. And I'm going to talk about it, and then at the same time, I'm going to run it. And that should save me some time and effort. And I can hardly even read it. Okay, so I'm going to do my best to try and glance over here rather than fiddle with the settings right now. But no, that's not going to work. Let me change the settings real quick. Perfect. OK, that's better. Now I can actually see what I'm doing. OK. It's the same. Perfect. All right. So thank you. Yes. Yeah. OK. So it's running in the background right now. It'll finish and it'll actually interrupt me because it's going to open up a radar chart, which like I showed before. But what I'm doing is I have a series of runners, much like I talked about before, and I just have some ones running via Olama locally. I'll just show you one here. It's a 323B, and it's just a named object, essentially. That's the result. Did interrupt me perfectly. But the runner just is some asynchronous function that just takes some context and some content they want to prompt with, and it just invokes that. And I define this. So the abstraction, the actual interface for this is defined within Langium AI, but you define the actual thing that you're invoking. So therefore, it's a runner. You invoke it. The other two are the same. They're literally also using the same one, just the model changes. Prompt is an abstraction for working with the llama. And the hello world example that I'm actually checking my one case, because it's a light example here, is just some expected response. It's basically a little bit of text and an embedded code section. Because maybe you want to have that. Maybe you just want completion. Maybe you just want raw code. It varies, but you would make the cases to suit what you're actually checking. Here, I have a little handy function that I've written that takes this Langium evaluator, which I'm not going to dive into because sadly it's a time constraint, I think. But it's just parsing my grammar that I'm expecting as a response, and then it's running it through the validation phase, and it's getting the metrics. So parser errors, lexer errors, additional diagnostics, and then it's computing those and then giving me an actual result. And the actual demo that I just ran for you guys that interrupted me there was this, which is just this matrix. It just has a config, some metadata, a number of runs to average over, and in addition, the runners themselves, my one evaluator with the name on it, and I called this, what is it? I said it was like merge before. It's really a sequence operation. It's not actually merge. Need to rename that. And then the single case. And then the result was run, and then I got a report. And that report is down here. They got my errors, warnings, infos, hints, unassigned, and a similarity measure is something I added. I was just doing 2 embeddings and just comparing them, much like the actual talk that was presented before, just doing semantic checking there. And then the chart that popped up was this one. So it's similar to before. The results always vary. Doing a live demo, I never know what you're going to get. I just do 3 runs. But the blue is Llama 3.2, 3B. By the way, smaller is better, as it says at the top of the chart. So that one is not great. The green one is also not great, which is Code Gemma. But Code Llama in here did fairly OK relative to the others. And again, this is just the apples-to-apples comparison. I just have 3 models. I'm not using RAG or anything. Didn't even give them context about Langium. And just ran them, and now I have some results. If I wanted to be more confident in those results, I would run with larger result, larger quantity, variations on those models, and actually start to record this, because the data is always recorded, and have a history for that. So it helps me build these kinds of applications. OK. And then let me jump back and run through so I don't crush it on time. Right. So overall, Langium AI supports developing AI applications for Langium DSLs, provides the stock splitting utilities and tools for evaluating your AI app performance. Facilitates iterative development of these applications, and it's agnostic of your actual tool. So you bring your own. And ideally, this helps assess, again, what you're already working on, what you're already building in the context of a Langium DSL. And some last remarks. Like I said, it's still an early project. It's work in progress. I don't have any nice QR code for you. Sorry. We're looking to push out 0.20 later this year, and I'll notify it probably like via blog and socials. And the plan is to expand on the splitter, the evaluator, and iterate based on practical needs, as mentioned before. Whatever needs this is not filling, we'll probably change it to fulfill those needs. And yeah, that's it. Thanks. OK. Am I good on time?